Hi, hello, namaste, namaskaram everyone. We are learning vector triple product today. Just like we have learned the scalar triple product, vector triple product is a vector thing. Scalar triple product, box ABC. This is not a box ABC or something like that. Just this is the cross product of three vectors, where one of the vector will be the outside, and two vectors will be in the bracket. So how to get the formula? Just remember this: A cross B cross C is equal to A dot C B bar minus A dot B C bar. Clear, guys? So how to do this is simply remember A is outside, no? So it will be going with a further away thing. What is a further away means? Who is far away from the A? B or C? C. So it will combine with the C. So A dot C into B bar minus, now who is the near? B. So next time is A dot B, A dot C B bar and A dot B C bar. Simple. Otherwise, if A cross B is there in the first place, who is away from C? A. So C dot A first. Who is near to C? Now B. Now first was A dot C B bar minus now B dot C A bar. Clear, guys? C will be combining with the A and B bar respectively. This one you have to remember. I hope this is clear, right? So once again I am repeating you: A cross of B cross C is equal to A dot C B bar minus A dot B C bar. If A cross B is first side cross C, then this will come. Which is outside vector? That will start, the outside vector will start with a far away vector. That means if C is outside, C will start with the A bar, then B bar. Clear, guys? Who is taking charge? Who is outside? I hope that is clear, right? Right? Then the outside vector plays a real role. That one you have to remember. For example, you play LBW thing, right? Let us use that. So if we have L cross B cross W, then who is outside? L is outside. So who it will combine with the B or W? Yes, obviously W is away, no? So obviously L dot W B bar minus. Now next time L dot B W. Otherwise you can use W dot L B bar or B dot L W bar. Doesn't matter. Okay. I mean, I have some kind of a formula to to mention. The thing is, like, you can use, if A cross B cross C is there, no, you can use that cab back CAB BAC. That I will explain in the video further in this same lecture. Okay, you no need to worry. So there are some things like where A cross B cross C will stay. It will stay in the same plane where B and C bar are there. Okay, but remember, vector triple product is not commutative. That means what, sir? A cross B cross C is not at all equal to A cross B cross C. That means what? If A is outside, cross B cross C in the bracket and A cross B in the bracket, cross C, not at all equal. Okay, just I was telling, where M cross bracket P cross L will stay. It will stay in the bracket thing. Who is in the bracket? P and L. So it will stay there. Okay, so once again I repeat, the vector triple product is not at all commutative. Remember, note, it is not commutative. Clear, guys? So no need to worry about it, right? Just like whereas A dot B cross C or B dot C cross A, all were commutative. Commutative in the sense like they all were equal to box ABC only. Clear, guys? Okay, the next one is Lagrange's identity. It simply denotes a scalar thing, right? Why, sir? See, A cross B dot C cross D. What is A cross B? A vector or scalar? Obviously a vector. And C cross D vector. Vector के बीच में क्या है? What is there in between? It's a dot, right? So what is this all becomes? Is just number, damn number, right? So it is nothing but Lagrange's identity will give us a number which is nothing but a scalar, which is nothing but A cross B dot C cross D is equal to A dot C, A dot B, A dot D, B dot D, B dot C, B dot D. Once again I am telling you, A dot C, A dot D, B dot C, B dot D. How to remember, sir? A will go with the C and D, B will go with the C and D. That much simple to remember. I hope it's clear, right? So remember this formula. Remember. This is very important. Clear, guys? Sir, what to remember from all these things? Simple. A cross B cross C formula. Then A cross B cross C will lie in the plane of B and C, and it's not commutative. And simply remember what is the Lagrange's identity. That much simple. In this lecture, nothing much is there. Simple, only 4 or 5 things I hope it's clear, guys, right? For your convenience, I'm like, once again I'm telling you, Lagrange's identity is very important because this will be asked in the exams very often. Clear, guys? Right, let us see how to do these things. Hi, hello, namaste, adab, namaskaram everyone. We are going to learn the vector triple product. As I explained already through the slides, I think it's a little bit clear. Let me clarify the further things in case if you have any doubts. These may be the kind of tips to just remember the formulae or just to understand the concept deeply. Clear, guys? Let's get started. So when we have a cross B cross C, B cross C in the bracket, I call like this. See, if we have a outside A cross B cross C, which is outside? A is outside, right? So which is outside, it will go with the further one. Between the B and C, who is like far away from the A? C, right? So this guy will be dot product with this guy and B will be standing outside. That means what? See, like this. See, A will be dot product with the C. So C dot A or A dot C, doesn't matter, right? Because both are same. I told you what is the commutative law. So it's like a C dot A or A dot C. Then simply B is outside. That means what? C dot A is a number, whereas B is a vector. Correct. Similarly, once A is done with C, then it will go with a B as a dot. Then who will stand outside? The other guy, C. So A dot B or B dot A here. Clear, guys? So which is nothing but A cross B cross C is equal to C dot A B outside into B bar minus B dot A into C bar. That means these both are vectors. That's why we call it a vector triple product. Earlier in the box ABC, which was a scalar triple product, it was simply a number. Box ABC was a number. But in this case, this is not a number. See, this is a vector. So C dot A is a number, no? Yeah, no problem. 7 into B bar is still a vector, no? Only the magnitude becomes 7 times. For example, for instance, I took as example as a 7. That's it. So what I try to say here is, we can remember this simply like this. I draw a car here. I'm going to explain that. So if you have a cross B cross C, the answer is going to be, you remember cab. See, during this corona time, cab is not possible, but just remember like this. Cab, B is a vector, minus cab is backside, B-A-C-K. I'm not going to write K. Just remember, just K for the OK. Okay, right. So A cross B cross C is, cab is waiting outside, backside. Which sides are backside? That means C dot A B bar minus B dot A C bar. I hope you can remember. Whenever you see the vector product, no, just remember this core thing. Clear, guys? So you can simply remember it. So I'm sorry, I'm not good at the core drawing things. Anyway, so that's how you have to remember this. Clear, guys? The next one we have learned is, sir, A cross B cross C is a vector. That is fine. That answer is this. We have to subtract this from this, which we will get a vector. But where is this, sir? One vector is here, this pen, and another vector here, and another vector here. If I cross product of these three vectors, where is the resultant vector will be? Is always in the plane of B and C. Remember, B and C should be in the same plane. Which are in the bracket should be in the same place. If B is on this particular plane, say P, and C is on this particular plane of where B is already there, then this A cross B cross C is in this. That means, where is A cross B cross C? Is in the same plane where B and C both are existing. Both are already there. Clear, guys? This is a C. This is a B. Okay, that is the second point. And third one, there are many, but I'm going to discuss very important things here. The next one is Lagrange's identity principle. Okay, in the vectors, this is very important. When we have a 4 vectors which are cross product to each other and dot product in between, means what, sir? If we have a vector, say A, B, C, D, then A cross B dot C cross D is nothing but, it is defined like this. See, guys, I'm not giving any proofs or something. I'm simply giving you hints how to remember this formula. Clear? When we start a real lecture, in the sense, sir, what do you mean by real lecture? When there is a board, due to this corona, there is no facility of board here, and when there is a blackboard or whiteboard with a marker and something, no, then you will clearly understand with each example. Those lectures will be little longer, maybe 50 minutes or 45 minutes. Clear, guys? So as of now, I'm just giving you how to remember this. Are you okay with that? Are you okay with that? Yes. So A cross B dot C cross D is, sir, how to remember this now? See, this A will go with this both C and D. B will go with the both C and D. Who will go first? A, obviously. So A dot C, next A dot D. Clear? Next one, B dot C, then B dot D. This is what the Lagrange's identity principle. So simply based on this you will get some value. Can you guess what is this? Is it a number or a vector? I mean, is it a scalar or a vector? Obviously it is a scalar, because there is a dot product. No, sir, these two are vectors. No, huh? What is the big deal? For example, this is a vector u bar and this is a vector v bar. U dot v is nothing but a number, right? Number means what? Scalar. Clear, guys? So by the Lagrange's identity, we are going to get one number. How to find it? Using the determinants. I hope that is clear, right? So let me revise again quickly. Is when there is a vector triple product thing or scalar triple product thing, remember, scalar means a number, vector means a vector. So in the scalar triple product, what you will get? In the scalar triple product, what you will get? You will get a number. Sir, what is that number, sir? Box. What is that box, sir? I'll tell you. Box A, B, C. What is that box A, B, C, sir? A dot B cross C. A dot B cross C. No. A dot. सांस लो, कोई बात नहीं, आराम से, धीरे से, ठीक है ना? You can eat samosa and come back, then say B cross C. Means what? A dot B cross C is a box A, B, C. What is this? A number, which we call in a mathematical term a scalar. Clear, guys? Whereas vector product is not a number. It's not a number. What is it? It's a vector. Sir, what is that? C dot A. Dot product is a number, right? Into B bar. B bar is a vector. So this becomes vector. This becomes vector. Clear, guys? So it's a subtraction of the things. Clear, guys? Remember the cab. Okay? Use the Ola or Uber. If any other there, you can use those also. But remember the cab. Where it is waiting? It is waiting backside. So just simply remember C dot A, B bar minus B dot A, C bar. Clear, guys? I hope you understand. We'll proceed with the other things, maybe with the examples and reciprocal of the vectors in the further lecture. Clear, guys? Thank you.